Howdy, it's me, Miss Elliott, and this is your quiz that you would like to correct. So we're going to go through every single problem. Our first set of problems are true or false, and they're based on this picture right here. So let's talk about this picture. We have two planes, plane M and plane N. And so on these planes, there are some points, there's some certain things going on. This is a flat surface, and this is a flat surface. Let's begin. It says R, S, and P are collinear. Well, in order to answer this question properly, we need to know what collinear means. It means they would all line up. You could draw a line through them. Share a line. So if I look at R, S, and P, R, S, P, I can't draw a straight line through all three, so they are not collinear. This is false. Point T, I know it's a point because it's a capital letter, lies in plane M. So on plane M, is point T on it? Yes, it is. This is true. R, S, V are coplanar. Now this is a bit tricky. Something that we need to understand is that 3 points are always coplanar. I can explain this some more whenever I get back tomorrow. There's only one plane that contains R, S, and Q. R, S, Q. Is there any other flat surface that could lie on those 3 points where those 3 points could lie? There's not any other flat surface, so there's only one plane that contains 3 points. 3 points define a plane, and 3 points are always coplanar. And so this one is also true. Name the intersection of plane M and plane N. Well, our nesting dolls here, point, line, plane, helps us remember that two planes intersect to form a line. So if we are going to name that line correctly, our notes told us that we can name a line with 2 points like A, B, and a line symbol, or we can name it with a lowercase letter. We'd have to type it out, line, M, for example. And so if I look at where these two planes cross, if we look at where these two planes intersect, this flat surface and this flat surface intersect all along this line. There are several ways you can name this line. You could name that line RS, SQ, or RK. And any of those reverse, so SR. Those were all your options. Name the intersection of a line and a plane. So if you're a straight line and you pierce a flat surface, you pierce a sheet of paper, for example, line M pierces this flat surface at point P. That's the intersection, point P. You don't have to type out point, you can just put P. Name the intersection of VT. All right, the line's not drawn, but we could see the path that it would take. VT would go through plane M. The intersection of VT and plane M is actually point T. So then we have this, our sometimes, always, never. This requires that we have a deep understanding of all of our vocab. 3 points are coplanar, so 3 points share a line. Does this happen always or sometimes? This tells us that this happens sometimes. If I have 1 point, it says an infinite number of lines pass through the point. Well, this line passes through this line, this line, this line, this line, and I'm just doing this on a two-dimensional surface. You could see that I could keep going. An infinite number of paths will pass through that point. So this one is always. 3 collinear points lie in only one plane. Now this one is quite difficult. If you miss this, don't beat yourself up. This one's really hard. So here we have 3 collinear points. Do they lie in one plane? Well, I'm going to use my highlighter here and draw one flat surface that contains them. So here's one flat surface. Just like I change the angle of my lines through the one point, I can change the angle of, say, a plane through all 3 of these points. And hopefully you can see this picture well that I am drawing out for you. That second orange plane also goes through all 3 points. I'm going to draw another plane, a yellow plane, that will go through all 3 points. This is better to visualize on computer software that can show you all these 3 points. However, this is the best we've got. But these 3 points are contained in 1, 2, 3 planes, and I could keep going and going all the way around and have an infinite number of planes. So this one, 3 points lie in only one plane. We can see the picture, we can understand that picture, but then what's the answer? Never. Why is it never? Because 3 collinear points will lie in an infinite number of planes. 3 coplanar points are collinear. Well, these points are coplanar. They're on the same paper, but are they collinear? No. So 3 coplanar points are collinear sometimes. A line has a midpoint. Well, if a line goes on forever and ever, can there ever be a true middle? The answer to that is no. And so a line never has a midpoint. Opposite rays, this is an example of opposite rays. We have a ray going in that direction, a ray going in this direction. Opposite rays form a line. This looks a whole lot like a line. Yes, they do, always. It's part of the definition. The intersection of 2 planes is a line, always. 4 points are coplanar. So here I have 4 points that are coplanar on this flat surface, but if I have 1, 2, 3, and you can't see the third because I'm have it up in the air above my iPad, that 4th point would not be on the same flat surface. I'm going to draw kind of like a 3-dimensional picture right here, where you can see that all 4 points on my little pyramid are not on the same flat surface. So 4 points are coplanar. That only happens every once in a while. That one sometimes. So this right here, if you found that you struggled with this is because you're not studying your vocab. All right, so get yourself into a study routine. If studying is new to you, this is the first time you've had to study, start small. Start with a Monday, Wednesday, Friday routine where you read back through your notes and you make sure you understand all the vocab. Let's turn to the back. Here, it says draw a picture. So, I hope you drew a picture, not only for this problem, but for the next. X, Y, and Z are collinear. They're on the same line. Y is between X and Z. Let me draw my picture. X, Y, Z. And we just did a problem just like this right before your quiz. We had looked at the segments practice and got some practice with us. We're told that XY is 2x minus 2 minus 5, 2x minus 5. We're told that YZ is 4x minus 9. And the xz, our whole, is 34. Is y the midpoint? Is y the midpoint? Draw a picture, justify your answer. Well, based on the information that's given, I'm given two parts in the whole. To determine if y is the midpoint, I first need to know the value of x. So we're going to find x by setting up a part plus part equals whole equation. 2x minus 5 plus 4x minus 9 equals 34. Our first step here is to combine like terms. Already we are forgetting this, that we practiced, we reviewed. I've seen a lot of people forget to combine like terms. So that means the x's will combine, the constants will combine. I'm gonna go ahead and color those in a different color. X's, and then make this a little bit smaller, and the other things, the constants. And so when we combine like terms, it immediately simplifies our equation. We'll have these two parts over here, and then whatever's on the other side is over there. So 2x and the 4x make 6x. The negative 5 and the negative 9 make negative 14. Add 14 to both sides. 6x equals 48. Divide by 6 on both sides. Here you might have used your calculator. And we find that x equals 8, but that's still not answering the question. The question is y the midpoint? So now I'm going to take this 8 and plug it in. 2 times 8, y 2 times 8, where did I get 8 from? Well, we solved for 8. X is 8, so 2 times x, 2 times 8, minus 5. 2 times 8 is 16, minus 5 is 11. Well, I already know that 11 is not half of 34. We can plug into the other side. 4 times 8 is 32 minus 9. 32 minus 9 is 23. That's correct. And so is y the midpoint? No. Y is not the midpoint because 11 does not equal 23. Our next problem tells us that J is between H and K. So if we remember from our first lesson on segments that anytime we see the word between, that means it's collinear as well. So H, K, J is between. We're told that JK, oh, my picture's not drawn to scale. Let me fix it. Not that yours has to be, but I'd like it to be. We're told that JK is 3x and that HJ is twice JK. So what is twice of 3x? Well, double 3x, or twice this amount, 3x times 2 is 6x. And then we're told that HK, the whole thing, is 72. So what pieces of information do I have? I have two parts, and I have a whole. Am I allowed to set it up? Part plus part equals whole? Well, yes, we are. 6x plus 3x equals 72. 9x equals 72. What did we do here? We combine like terms. And so divide by 9 on both sides. And we find that x is 8. So we solve for x, but we're also asked to find the length of JK. So 3 times 8 the length of JK is 3 times 8, which is 24 units. Alrighty, so most of us just did pretty great here. A few of us left this blank, and in those folks' defense, I wasn't here to teach you this. So I'm gonna take a little bit of extra time with these two problems. Find the distance between these 2 points. The distance formula reads x2 minus x1, so we subtract in the parentheses and then square. No matter what we get here, when you square it, it will be positive. Then we add it to the squared difference of the y's as well, y2 minus y1. And so I like to label my points. I also like to let the positive x be my x2. It really doesn't matter which one you allow to be x2, y2, as long as x2 goes with y2. And so here's how I'm going to label mine. This is my x2, y2. This is my x1, y1. Now we simply plug these numbers into the formula. So let's do that now. The square root of x2, what is x2? x2 is 4 minus negative 2. That double minus is going to turn into a positive. We'll handle that in the next step. y2 is 3 minus 1. y2, 3, y1, 1. And so next we continue to crunch our numbers. PEMDAS tells us to deal with what's in the parentheses first. So 4 plus 2 is 6 squared, plus 3 minus 1 is 2 squared. The 6 squared is 36, is not 12, never has been, never will be. 36 plus 4. 36 plus 4 is 40, so the distance between these 2 points is the square root of 40. Will I accept a decimal? Not really. If you gave me an approximation that was rounded to less than 2 decimal places, I did not accept it. If you're going to round, you need 2 decimal places. So the distance is approximately 6.32, but this is a perfect answer right here. What's the midpoint? Midpoint is the easiest formula. It's my favorite formula. Why? All we have to do is add and divide. And all kids in high school know how to add and divide. So the formatting is important that we understand what we're finding. We're finding the location of a point. So when on a coordinate grid, the location of a point is given in an XY coordinate written in parentheses. And so our final answer needs to be in parentheses because I've asked for a point and its location. So this is our final answer is going to be in parentheses. We add our x's, and it really doesn't matter what order you add in, and we add our y's. So all points go xy, xy. So if I add my x's, I'm adding -1 plus 1, divide by 2. Add my y's, adding -8 plus -1. -1 plus 1, well, these cancel out, and we're left with 0 over 2. What is 0 divided between 2 friends? Nothing divided between 2 friends is still nothing for each of them. -8 plus -1, we get 2 negative things. When they come together, they make a bigger negative number, so to speak. And so this is -9. -9 divided by 2, you could leave your answer just like that. Or you could tell me -4.5. So hopefully your quiz is corrected. Go ahead and turn it in to the back table and work on your review for the rest of class. Make sure that your angles practice and your more angles practice are both complete. There's a wealth of things for you to do. So let me put that here. What now? This is your checklist. So, angles practice, that's due at midnight. Is that done? More angles practice. Is that done? Did you get up to a 100? The Unit 1 review. You should be nearly complete with that. We'll be working on it in class tomorrow. And if you are done with all of these things, flashcards, making them, studying them, and reviewing your notes. I know we went through this very quickly, so I hope you paused and took your time getting your corrections done. See you tomorrow. Bye.